Okay, so one of the equations that we're going to end up with is negative 22 cosine b value is pi over 18. T, there's no phase shift, and then plus 23. Another one would be h of t equals positive 22 sine pi over 18 and then brackets t. Sine function starts 9 units to the right, so t minus 9 plus 23. Third one could possibly be h of t equals positive cosine, so 22 cosine pi over 18 t minus 18 plus 23. And the last one could be h of t equals negative 22 sine pi over 18 t minus 27 plus 23. Any one of these equations will work. In fact, if you're going to graph these equations, every single one of those would give you the exact same graph. Right? They all generate the exact same graph. Each equation is just representing a different phase shift than the other. Okay, now that we've got our equation, we can use any one of them to try and help us solve the next part of the problem. How high above the ground would a person be 24 seconds into the ride? So we're trying to solve for h of 24. So when time is 24 seconds, what's going to be the height? We can do it one of two ways. We can do it algebraically. So algebraically, we just take one of these equations. I'll use the first one here, and I'll plug it into that equation. So h of 24 is going to equal negative 22 cosine pi over 18 brackets 24 and then plus 23. When you evaluate this, you're going to plug it into your calculator as such. That pi over 18 and the 24 are together. So when you're taking the cosine of, you're taking the cosine of both of those numbers. So on the calculator it would look like this, negative 22. Again, make sure in radian mode. Cosine of in brackets. I'm going to put another set of brackets for that fraction. Pi divided by 18. That's being multiplied by 24. And then I'm taking the cosine of both of those, and the answer I'm going to add 23 to. And the answer you should get is 34. Or you can do one more step and simplify it here first and get negative 22 cosine of pi over 18 times 24 is the same as 4 pi over 3, and then plus 23. And when you plug that in, you end up with 34 meters as the height. So height after 24 seconds is going to be 34 meters, which should make sense on your graph. Go back and double check and see if it makes sense. So 24 seconds in, okay, you're going to be in between sort of the 18 and the 27. So 24 seconds in, you're going to be around 34. Yeah, it makes sense looking at the graph. We can also do this graphically, right? To do it graphically, we have to graph this equation. So we'll graph y equals negative 22 cosine of pi over 18 x plus 23. And then once you've graphed it, we're finding y when x equals 24. So we're going to go second trace value X is 24, and then what is Y gonna be? You may have to adjust the window settings of the graph for it to fit on your graphing calculator. So let's see how we would graph this. First things first, you want to make sure that in radian mode, window settings, you'll notice that original graph, we went from 0 all the way until 72. We're doing scale factor of 9, going up by 9 each time for X values. Y values, we went from 0 all the way up until 45, so I'll pick 50. And going up by, say, 10s. And then the equation will go in here. Y equals negative 22 cosine, another set of brackets, pi divided by 18 x, bracket close, and then plus 23. Okay, that pi over 18x, you're taking the cosine of both things. So that's why it's got to be inside set of brackets. And the pi over 18, I'm putting it in brackets, otherwise it's not going to recognize there's a fraction there. It's going to go cosine of pi, take the answer, divided by 18. Now when you graph it, your graph's going to be the exact same graph that we drew. This is the exact same graph that we drew. We want to find out what's going to be the y value when x is 24, so I go second, trace, value. When x is 24 on this graph, what's going to be the y value? The y value is going to be 34. It tells you what the y value is. The y value is 34. Similarly, I can ask you to work backwards. How many seconds is a person more than 30 meters above the ground? This is where algebraic approach is not going to work, right? Because more than one answer. What the question is saying is that somewhere along the ride, the person was above the height of 30 meters from the ground. We want to look at and see how long was this person above the height of 30 meters. So we have to solve this graphically. If you look at the graph, what this is representing is somewhere along the graph there is a height of 30 meters. Right. We want to figure out that this person went above 30 meters right here. He came back down 30 meters over here. We want to figure out how long was the person above that height for. So we're trying to find out what the T1 comma 30 is. Trying to figure out what the T2 comma 30 is. And then to figure out the time above 30 meters, we're going to go T2 subtract T1. Alright, so T2 subtract T1. That's how long the person was above 30 meters for. Alright, so to solve this, we need a graphing calculator again. I've already got the function graphed in. I want to figure out when that person's going to hit 30 meters, so I'm going to go under y equals. Under y2, I'm going to plug in the number 30. y2 equals 30. And then press graph again. So you're going to get a horizontal line that represents y equals 30, a height of 30 meters. I want to figure out how long was the person above the height of 30 meters. The person was above the height of 30 meters at the first point of intersection. The person came back down 30 meters or below 30 meters at the second point of intersection. So whatever the time difference between here and here is, that's the time the person stayed above 30 meters. For that time, the person's height was above 30 meters. I want to figure out what those times are. I'm looking for the two intersection points. You know how to find intersection points? You go second, trace, intersect. Okay, go really, really close to the first point. So take your cursor, get really, really close to the first point of intersection. Once you're at the first point of intersection, you're going to press enter 3 times. Once, twice, 3 times. And you're going to get the x value. So y is going to be 30. when x value is 10.8553. So my first point is 10.8553, 30. That's the first point. My second point, T2, I want to figure out. Now, I would repeat the steps. Go second, trace, intersect. Scroll over to the second point this time. Get really close to it. And then press enter 3 times. Once, twice, 3 times. You get a value of 25.1447. So 10 seconds into the ride, the person goes above 30 meters. 25 seconds into the ride, the person comes back down below 30 meters. So the time the person was above 30 meters for is going to be 25.1447 subtract 10.8553, and what does that work out to? 14.2894, correct? I'll round to the nearest second, so approximately 14 seconds. So the person was above 30 meters height for approximately 14 seconds. When you're given the x value you want to find y, is simply second option number 1 value, right? You plug in the x, it gives you the y. When it's the other way around, you're given the y, you want to find the x value. It's a little bit more work. You have to graph the second y value as a second function and then look for the intersection points. The following data shows the tide heights every 2 hours for a certain location. So now we have a sinusoidal function that's going to represent time and height after that time. Height of the tide after that time. So we have to first go ahead and graph this data and see what kind of equation model we come up with. So time is our independent variable. It's going to go at the bottom over here in hours. Hours after midnight, and the y values are going to be represented by height, which is going to be in meters. Setting up our scale for the x values is really easy. Just look at the data that's given to you, see how far you need to go, what you need to use. I'm going up in scale factors of 2, so I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, and so on and so forth. I'll go up by 2s. If I look at the data going up in terms of height, my data fluctuates between 1.4 all the way up until 7.8. So really I'm going from 1 all the way until 8. I want to set my scale accordingly. Let me see if I go up by 1s, that'll do the trick. Do I have enough space? 2, 4, 6, 8. Yeah, I'll have enough space to go up by 1 unit each. And now it's just a matter of me plotting that data and see what I end up with. So I'm going to start plotting all those points individually. At 0, 0, I have a height of 6.3. So 6.300 is going to be roughly over here. At 2, I have a height of 7.8 here. At 4, I have a height of 6.1 here. 6, I have a height of 3.2 here, and so on and so forth. I'm going to go ahead and complete graphing the rest of this data and then see what I end up with.